And we're live. You're listening to Interchain FM, the Cosmos radio station. If you're seeking alpha in the cosmos, look no further. I'm your host, Chango Unchained. Before we get started, I'd like to share a little announcement. If you've been an enjoyer of Interchain FM, we are about to get online as a Celestia validator. That is happening imminently. So if you would like to help a sister out and stake with us, I would very much appreciate it. This podcast is for your education, and I serve it to you as a public good. So tonight, we're here with Bo, the founder of Polymer. If you need a primer about Polymer, we did an episode with him, and that is linked in the YouTube description below. And we're having him back on the show the second time around at the heels of mainnet launch, which is also coming on imminently. So, Bo, Gamolimer, I understand. Gamolimer.
so yeah.
Can't even keep a straight face saying that. Yeah. GM, I understand you're in Thailand right now, so it is your morning.
Yeah. I'm here for a few like research conferences and DEF CON, of course.
DEF CON in particular.
Yeah.
Yeah, good to have you back. And, just to give credit where credit is due, I need to applaud you, the Polymer team, as well as Peter for taking up the mantle for IBC, since you guys were doing God's work, taking IBC, building a summit around it, and going on a whirlwind tour across the whole globe, bringing IBC to the masses. This is the kind of ecosystem development that the Interchain needs. So, yeah, that's amazing that you guys are doing this.
Yeah, absolutely. And like from our vantage point, we can see that the Interchain's expanding like far beyond the cosmos, and soon on Ethereum as well on mainnet, which is awesome.
That is really exciting, and that is what you are here to share. Tell us more about that. How is IBC going to operate on Ethereum when you launch mainnet?
Yeah, so the protocol itself is separate from the verification layer or the stuff that's under the hood. So the car, maybe like analogy here is the car is IBC, like how you drive it, how it feels, and then the engine itself is going to be a little bit different. For example, maybe we can think of like IBC in the Cosmos as having a Comet BFT powered engine. But when you're dealing with rollups and you're dealing with rollup settlement, it's not the same thing as consensus. So that engine is going to look very different. And there's going to be different types of engines for how fast you want to go. So if you want to go like super fast, you want like 1,000 horsepower, that engine is going to be more or less sequencer powered. And if you want to, cruise, you're moving a lot of weight, maybe it's like a large truck or something, you want a lot of torque, but you're not going to have as much speed. Maybe that engine is the rollup native bridge, meaning that you're waiting for these rollups to settle. Going to go a little bit slower, but it can carry a lot of weight with it. So maybe that's an analogy for the non-technical folks.
That's a really good analogy. I understand that completely. Which one's the EV and which one's the gas-powered one? Which ones are the hybrids?
Yeah, that's a little more nuanced. Perhaps like the EVs could be, and there's a lot of innovation that's happening within Ethereum. I think it's funny because with the Cosmos, you had a lot of these forward-looking problem solvers really from the get-go work with a disconnected network of chains that were not unified. A lot of technologies were invented to unify that network. Now we know it as the interchain. And on Ethereum, it was previously unified. It was just Ethereum. Now with all these rollups, with all this fragmentation, they're encountering a lot of the same problems that we did in the Cosmos. So you see them trying to innovate within the confines of their problem domain. So perhaps like if I were to draw an analogy for electric vehicles, an electric vehicle engine could be perhaps even powered by the verification system of like superchain native interop. At the moment, the spec for superchain native interop is actually more of like in IBC land what we would describe as an IBC client or a verification mode. not necessarily a messaging protocol. Which means that you can technically use IBC messaging over superchain native interop as a verification layer, which is kind of interesting. Back to the point of like swapping out engines. Like you can always swap these engines to different things.
Yeah, so the problem space that Cosmos was reasoning through was that, okay, we're going to start off as an multi-chain horizontally scalable cross-chain solution with like a native communication protocol, but then Ethereum sort of had to shoehorn that in as it developed, like, as it grew into this sort of like roll-up ecosystem, and so between a lot of its roll-ups were these bespoke bridges with their own tolls and their own rule sets, and there's no standardization across all of them. So now Polymer is bringing the best of the Cosmos to the Ethereum ecosystem and introducing this more standardized practice. And I don't know, maybe the analogy would be like you're Elon trying to bring like Tesla engines to Ethereum, so to speak, right? How does that? Yeah, how does that work? You're doing cross rollup communication as well as the rollup to main chain communication, right? So it'd be like Ethereum main chain, and then here's like Arbitrum, and here's zk Sync or whatever. But you're able to do like any sort of like bilateral communication.
Yeah, we can, but I want to say that we're focused primarily on cross rollup. We think that the most value in the long term is going to be cross rollup. The way that it works is we have this protocol that we call virtual IBC, where we offload most of the IBC messaging logic, the stateful part of it, onto Polymer. IBC is a stateful protocol. Either you commit to IBC state on the chain itself, or you commit to that IBC state on a different chain. And our strategy was to commit to that IBC state on Polymer instead of the chains themselves, meaning that our integration contracts are a little bit more lighter weight, because we do want to optimize for efficiency and performance. And right now we support IBC Classic. The ICF is working on another version of IBC called IBC Eureka or IBC v2. It does modify some of the constructs, makes it easier for perhaps Ethereum devs to work, or EVM devs to work with, because some of the things that people have complained about in the past, like needing to set up channels, needing to set up connections, the handshake process and how long those take, and the complexity of managing these are being addressed in this v2 version, which we also plan on supporting. So, and any future version of IBC, of course, will also support that as well. So that's how the IBC side works.
Before you move on, let me just stop you there. Is it backwardly compatible with IBC Classic?
I believe IBC v2 is.
Okay.
The IBC team has made it so that technically you could deploy a set of, or supposedly you could deploy a set of IBC Eureka contracts onto an EVM chain and be able to connect that EVM chain to a regular Cosmos chain that's running IBC Go. So they would be able to connect directly even. And then there's some like details that in how this is managed, how like the mappings between clients are mapped to channels and so on, some of these other IBC constructs. Yeah.
Okay. And so what's the Polymer chain doing, right? It's holding state across all of these different rollups. So is it kind of like a proxy chain that acts as the canonical sequencing of transactions across these different chains, and then later you checkpoint into, I don't know, like a DA chain?
Yeah, we do. Although Polymer is not a shared sequencer. It is not a sequencer by any means. Perhaps you could think of it as a sequencer or shared sequencer for cross-chain transactions. But
Well, what do you think of it as?
I think of it more of as a like cross rollup of messaging queue. So that's IBC enabled. I like to draw an analogy to Web2 technology called Kafka. So for those of you who don't know what Kafka is, Kafka is a messaging queue system that in the microservices architecture, where you have an application that's split up into many tiny services, many of these services will, instead of interacting with each other directly, will stream messages through Kafka. For example, when I worked at Uber, the Kafka team was one of the largest, had the most dependencies, and arguably did the most throughput out of all the infrastructure teams, had the most hardware, et cetera, et cetera. A lot of teams really relied on that team in particular to make sure that all these microservices could communicate and coordinate with each other.
Okay, and in this case of basically two independent blockchains, why does there need to be this Kafka intermediary?
Yeah, so I think with the existing architecture, the way that exists today, having this intermediary increases the efficiency of the system overall. So we ran some raw numbers on, let's say you take the weakest security model. I'm just going to call it a one-on-one multi-sig. So that this is as weak as you can get. You're trusting a third party, you're trusting a single entity. And you were to say, I want to have 100 rollups, and I want these rollups to communicate with each other maybe like one message per second. And what you start to look at, what you start to see is that if it's all-to-all communication, and this entity is signing off on these messages at, like I said, per second rate, this ends up being like tens of thousands, millions of dollars per year in cost and overhead. With Polymer, you can reduce that overhead to hundreds of dollars or just thousands of dollars on an annual basis. And this is due to like n-squared communication complexity. It's not as big of an issue when there's only like 5 rollups that really communicate frequently, but we expect that to change. There's hundreds of rollups coming online, and these rollups are increasingly like gaining traffic. And as these rollups start to interact with each other, this becomes more and more important. And on the long-term time horizon, we expect that as applications scale, they'll need to be horizontally scalable as well. So in the Web 2 setting, most people don't realize that a lot of these Web 2 companies actually run tens of thousands to hundreds of thousands of servers to power the backend systems. Meaning that if an application is truly successful, quote unquote, an internet scale application, their application would likely split into many different clusters of purpose-built or app-specific or workload-specific app chains. And this evolution of, I guess, like a microservices architecture on Web3 is likely probably going to occur in the next 3 to 5 years.
Right now, what sort of behavior do you observe users doing when they're doing this, like these cross rollup transactions that that necessitate such an architecture?
Today, no. Like applications aren't at that scale. We don't truly have like a Instagram on chain. We don't have an app that services a billion daily active users. Like it's we're a little bit far. Yeah.
Right, because from how users are using the chains right now, and as well as how the rollups are serving those demands, is they are still trying to be walled gardens, and and the only time that they checkpoint back into the main chain is for inheriting security, ostensibly. So, but you want to reduce the latency of cross rollup communication for a reason. So what is it that you see in the future?
Yeah, so on the topic of walled gardens, a walled garden, I guess, traps applications within when these applications don't have low latency access to primitives that exist outside of that garden, if that makes sense. A lot of these like layer 1 blockchains, you have every one of them, or even these layer 2 ecosystems bootstrapping their own DeFi. You kind of get this like highly competitive landscape where you have a lot of competition within a single vertical, a single category of applications. The idea is that if you can reduce the latency between these rollup ecosystems, you increase the network effects of an ecosystem as a whole. So Ethereum as an ecosystem as a whole, the network effects are improved. And you have less of a need to because there's an existing composable building block that you can access at milliseconds latency or at seconds latency away to bootstrap your own DeFi ecosystem, if that makes sense. Because then
Yeah.
yeah.
I would say that does mirror the architecture that does exist in the interchain ecosystem.
Yes, exactly.
Right?
Yeah.
Right. So we do have sub-second finality across two disparate blockchains that speak the same communication language. But then the problem is we still haven't seen the resolution of PvP across these chains, because there's tokens involved, there's tribalism involved, and with these ETH rollups, there's the same dynamic, right? So right. So I'm still hopeful about seeing like killer applications emerge that would utilize all this block space from these various chains horizontally.
Yeah.
That being said, empirically we haven't necessarily seen that done in the wild.
So our thesis there is that we see that there's a compelling argument for building things on chain that can only be built on chain, and a lot of that today kind of exists at the intersection of regulatory arbitrage and some level of social coordination. You have DeFi, you have meme coins, you have NFTs, liquid attention, so to speak, and these things can only be built on chain for these reasons. But for stuff that doesn't have to be built on chain, for existing categories of applications, we think that the major blocker there is latency. So if you look at existing categories of applications, whether that's social media, whether that's e-commerce, and you look at some of these studies that these companies in these categories have conducted years ago, sometimes like over 10 years ago, the Amazon, I think back in 06 or 07, conducted a study where for every 100 milliseconds of latency, Amazon would lose 1% of profit. And that was like tens of millions of dollars then, and it would be $5 billion per 100 milliseconds of latency now in lost profit. If you look at some of these social media sites, they also did some of these studies, or actually Google did a study where page load times and drop-off rate, where every like 100 millisecond of increase in page load time, you would see a significant drop-off in the number of people that actually stayed on the page. And I think attention is trending downwards over time. And because attention is becoming so scarce, given there's so much information overload, to compete in the existing category of applications, you have to at least not start with a tremendous handicap. If you're starting with a 6-second handicap, like a consensus level handicap, or you're starting with even like a 500 millisecond handicap, it's very difficult to even get started within this category, much less win and scale to the number of users that an Instagram has.
Yeah. So is Polymer opinionated about which underlying chains it supports, or is it going to be agnostic?
So we're pretty opinionated. Well, we will support, eventually support connecting to all types of chains, but for now we're focused primarily on rollups because we think that the rollup architecture is the best path forward to achieving the kind of latencies that can make an application competitive.
Because there's only one sequencer for each
yeah,
of them?
exactly. There's trade-offs here, right? Like, a rollup can never, a layer one can never be quite as fast as a rollup that uses a centralized sequencer, because a rollup can basically, the block times are arbitrary at this point. However fast the computer itself can execute, you could tune up the block time to even less than 1 millisecond. I know that there's teams targeting 1 millisecond execution latency in mega ETH. But additionally, it's also a geolocation problem. Layer ones exist globally in a global context, meaning the nodes can be distributed all across the world. Rollups with a single centralized sequencer can be located or co-located to a specific region or even a specific data center. So our long-term vision is that rollups will start to centralize in different locations, and applications that want to build the best experience for their users will use these low latency rollups and deploy their app across multiple regions to get the best service. Because like you can't fight physics. If you have to,
ultimately it's capped at the speed of light, right?
yeah, exactly. Like if I'm in Europe, like I don't want to be accessing a server in Asia, or if I'm in Asia, I don't want to be accessing a server in North America. I want to be accessing a server that's local down the street or something that's very close to me.
Yeah, sure. So how are you supporting the various rollups with IBC? I mean, if it's all rollups, does that mean it's going to support the EVM ecosystem, Celestia rollups, Initia rollups? How, like, where does it end?
We're focused on Ethereum rollups for now. Um, that problem space is the most unsolved right now, and we think that that's going to be the biggest market for us long term. So we're starting with the L2 to L2 connectivity, and we're starting with OP Stack. Our actual underlying architecture is a mixture of Cosmos and OP, and we want to target like full coverage of every OP Stack rollup within a few months after launch.
Yeah. So if these rollups are speaking IBC, does that mean that from the Cosmos perspective, we would be able to perform transactions with EVM rollups out of the box?
Yeah, that's correct. Although, like initially, we're trying to get to expansion across the different rollups. So, like Polymer to Cosmos connectivity is going to happen a little bit later on in our roadmap. Although it can work, it's just that we're not prioritizing the work at the moment to get it done.
Well, so like specifically, how does it work? Because if they're speaking IBC, I imagine this is like there's this standard communication. So is it not true that if I'm trying to perform a transaction from Osmosis and like I want to, I don't know, IBC and deposit some money into Optimism, let's say, could I do that
Yeah,
eventually?
you could. You could. The semantics would be the same, more or less, because we commit to the IBC state on behalf of the rollup. The rollup, from the perspective of the rest of the interchain, at least from the IBC state perspective, looks like just another Cosmos chain. That makes sense.
Mm-hmm.
Just like
Yeah.
how, like when you connect to the internet with your computer and your computer speaks TCP/IP, at least at the network level, everything looks the same. Everything is like a node that speaks TCP/IP. The actual like hardware, the operating system, the type of device is technically abstracted away on the internet.
Mm-hmm. Mm-hmm. Okay, that's huge. I mean, it's that's amazing. When would we be able to realize that? Like, when would I be able to make that transaction?
Within a few months, I think after launch, but also like the applications themselves would have to be deployed on both, which is a prereq. But as long as like the applications are deployed and the connections are set up, then IBC enabled communication would be possible.
What do you mean the applications need to be deployed on both sides? Smart
They
contract?
need to be, yeah, it's like a smart contract. The actual like EVM IBC app standards are still, I guess, like TBD on the implementation of some of these standards.
Okay. What like materially? What would that mean if I'm trying to deposit some money from, let's say, Optimism into Osmosis? Then does that mean Osmosis needs to have an Osmo smart contract on Optimism?
No, I'm referring to the standards. So it would need to have some sort of like ICS 20 token contract, and you would then construct like an ICS 20 channel between the two, and then you would be able to send across this. But unfortunately, because IBC token denominators are denominated in the route that it takes, that would be a different token than a token like minted by a different bridge.
What is okay? So does that mean that for each token, it needs to be manually integrated?
Yeah, like every token would have to be a separate contract, essentially.
Oh wow, that's actually quite a
Yeah.
much heavier lift.
Yeah, it's
Mm.
not a native. So like in the Cosmos, ICS-20 is a native module in the chain itself. Um, on the EVM side, it's not like there's no like native ICS-20 module in the
Mm.
node client, if that makes
Yeah.
sense.
Right. Okay. So yeah, right. So back to Polymer. Where does Polymer fit in?
Polymer is just establishing the connections and acts as like a verification conduit between these separate chains.
Hmm.
So
And is Polymer going to be implementing these uh, token standards, these non-native token standards?
So we'll adopt whatever token standards other folks implement. Right now we're not planning on implementing our own token standard. Like, for example, Layer Zero has their OFT standard that kind of locks the token into using their protocol. We plan on working with existing standards like in ICS-20 that the Interchain's working on, and XCRC-20 that a number of the EVM folks has worked on. And recently, actually just today, the Uniswap and Optimism announced a new uh, bridge agnostic token standard. We'll likely just work with all of these different standards on top.
Yeah. Are you actually working with the Ethereum teams? And
Yeah.
and like what's their perspective on this? You know, because Ethereum does lack a standard communication protocol, and they've known about IBC since before Cosmos mainnet launched, right?
Yeah.
Like, so what's their take on this?
The rollup teams themselves are pretty much just going down the path of building their own interop. They
Each of
don't.
them trying to build their own bespoke interop solution.
Yes, yes. I think unfortunately that's just going to be how it is for now. There is some effort at the EF level to try to standardize around things like chain IDs and perhaps additional things as well. I think uh, more like in the weeds things around like how can rollups share a single bridge. So like how do you separate proof systems from how you establish its cross rollup dependencies across these rollups? There could be things that could be standardized. In terms of the actual messaging standard itself, what I've noticed is that most rollup ecosystems are focused on just the ability to send a message with the expectation that that message is always received. IBC operates on different assumptions. IBC operates on the assumption that if I send a message, it may or may not be received by the destination chain, meaning that it can potentially time out. So these are fundamentally different assumptions. Um,
And you have to bake that in. Mm.
yeah. So like if their assumption is that if I send a message, it's always received, that there's no chance of timeout, or it just stays in limbo forever, um, then they're not going to want to use the IBC messaging design.
Hmm.
And I think like because IBC like considers incentives and other things, they wanted to ensure that there's an out for a user in case there's for some reason that their message never arrives at the destination chain.
Right. So what are how do they reconcile that? So the I mean, so they prefer for a transaction not to time out. I'm just having trouble with it because like these are the same people who like 7-day exit periods, right? And so like what's a timeout? I mean,
Yeah, I mean, like I said, they make the assumption that if you send a packet, it will always be received. Um, I maybe the thinking around that is like some ecosystems do treat their like cross rollup state as a single giant state machine. So if you look at like ag layer in the Polygon by Polygon, you can see that all these ag layer rollups share the same token bridge, and in order to like make cross chain calls, you essentially like zk prove the execution of the state of all these rollups. So when you make a call on one end, they always like Polygon itself, the ag layer itself will just automatically execute that transaction for you on the destination. Um, because it's just a single giant, more or less a single giant state machine that's connected by these ZK proofs. I think making that assumption is reasonable. But if you want to go across state machines, I think that's where an async protocol like IBC, at least at the messaging level, could make sense.
Yeah. Okay. So those are two different. I guess it would be security assumptions between how Polymer implements it and AgLayer.
Well, to me, it's sync versus async composability. If you ZK prove everything in the AgLayer, and you basically like merge those proofs together to kind of step through the execution of all these rollups, that to me is more like similar to synchronous composability than async composability. When you're dealing with async composability, and maybe the reason why I feel like it hasn't come up as much, like the timeout question, is because a lot of these async interop protocols that exist on Ethereum today, a lot of the folks actually building the bridging protocols on top are the same entity, if that makes sense. If you're the same entity building on top of a messaging protocol, you can pretty much guarantee, or you can make the guarantee yourself that you're going to deliver something. Like if I send something over my interop protocol, I better actually deliver it, because if I don't deliver it, these user funds are just locked in limbo forever, if that makes sense. But for folks actually thinking really hard about the problem, I think that's like an invalid assumption. You can't assume that just because if you send something async, that will always be received, which is why a timeout is necessary.
What about the people who say, okay, I'm going to trust Arbitrum always, and Arbitrum is always going to be self-incentive aligned to deliver my transaction?
Yeah.
And they don't necessarily think about maybe Arbitrum's founder is going to go to jail or something. Or maybe Arbitrum majority of the token supply gets bought up by BlackRock behind the scenes, and then it's just like a hostile takeover, and it's just like BlackRock chain. Is that sort of the edge case that you're building for?
So this property, like timeouts, that's an IBC property. So I wouldn't say that like we've introduced this feature into IBC at all. We just
I mean like like why is it a problem that these why is it a problem that Arbitrum, Optimism are building their own bespoke bridges, and why do you want to do it async?
Oh, well, the async property is natural when you don't treat when you don't treat the entire system as a single giant state machine. In the I'll say like the design of like ARB and OP, maybe they may want to make this assumption. If you have to have some sort of like incentive to send a message, you can end up in situations where that incentive is not enough. For example, like I'll give you an example is like if you submit a transaction to the mempool, if every mempool transaction has an incentive, unless you have an agreement with the validator that says, I will execute every single transaction that you send me, which that'll be a backroom deal. And you'd have to like, you and the validator would know each other, and you can make this sort of deal. But unless it doesn't work that in practice, but I'm just trying to give an example here. But in practice, there's an open fee market. If there's an open fee market, this means that there will be transactions where the fee is just not enough, or perhaps the demand spikes. And in those situations, you could have a transaction sitting in the mempool for months, even. Like for example, like in like early DeFi summer, I issued a transaction on Ethereum that like got executed like 6 months later because the fees just weren't enough. I had to wait for the fees to come down. Unless the user wants to wait, in the same situation, to have their funds stuck for that period of time, they need an out. But the systems that are being designed today don't take that into account. There's no open fee market. It's kind of like I'm a centralized entity. I charge a fee, and whatever, as long as you pay my fee, I will guarantee delivery.
Is that how AgLayer works?
AgLayer treats their all the blockchain or all the rollups in their ecosystem as the same state machine, more or less. they step to the execution of the rollup. It's not async.
I mean, what are the incentives that power ag layer?
Ag layer would take fees, execution fees for all the rollups, and all the rollups share a single bridge. The actual financial
Right, so
deals that are
it's
made,
trusted, right?
well, they prove the execution, but in terms of the fee model, you're making a deal to join the ag layer, to join their ecosystem. And
Right. So it's
yeah.
like it's one entity, they're performing a service, they're the ones taking the fees, and it's not really a market.
Yeah, exactly.
If you introduce a marketplace, would that introduce some perverse game theoretical outcomes like gas fee auctions and bidding them up and sandwiching these cross rollup transactions and therein create MEV across these different rollups? Would that happen?
They would have to purchase the block space across different rollups, because the block space in question isn't like, there's no like inherent like in between rollup block space. But if you're sending transactions between one rollup and the next, the block space on both matter, or I guess on the destination, once the source transaction has been executed, matters. So if someone executes on source, you could have someone like purchase block space on the destination chain and just like not accept that like cross rollup transaction. Like I'll give you an example here. Let's say someone has taken out a loan, cross chain loan, and they're in danger of being liquidated. And they want to like top off their loan so that they don't get liquidated. In theory, someone could purchase this cross rollup block space and prevent them from topping off their loan, so that they can like liquidate this for themselves, and they can calculate how much EV there is depending on the size of the loan, etc.
Yeah. By the time Polymer scales up to the, let's say thousands of rollups that will emerge in 5 to 10 years time, let's just say that, play out that scenario. And we have some pretty big applications running on top of this architecture. Do you think that would become a real problem? Like it's theoretical right now, but
so this problem is not unique to cross chain. You have the same problem in regular like L1s and L2s like individually themselves. For example, like if you look at Solana, this is anecdotal, of course. I remember during like times of high volatility, the Solana network would get DOSed, and a lot of folks that have like a lot of stake in these lending protocols would get liquidated because their transactions just fell because the Solana mempool is clogged. They're not able to get their transactions through. Whether these were actual real attacks by coordinated actors on Solana to liquidate loans, or if it was just a byproduct of the high volatility and just a lot of people trying to transact, regardless of the case, you end up in the same situation where someone got liquidated. And if there was block space auctions on Solana, like on Ethereum, you can kind of work with builders and proposers to purchase some block space. That I can imagine that someone could come in and instead of just DOSing the network, purchase the block space ahead of these other I guess like debtors and perform the same kind of attack.
Yeah. It's very difficult to build a global scale application where there are these perverse incentives built in natively to the underlying architecture. I will say that. So that's why we've only seen mostly financial applications built on it. Right. It would be kind of strange to see like an Uber app running across these chains and then like someone DOSing the network because there's a financial incentive to censor, and then some like user in Podunk, I don't know, Texas or whatever, can't get a ride in the future because it's like running on some blockchain architecture.
Yeah, that's actually an interesting problem to think through. Like if there are I guess marketplace attack vectors for markets that aren't financial, like the Uber example would be like just fundamentally a rider and driver marketplace. But then again, like I'm not sure how much value there is to extract from that type of marketplace. So I guess it's a question mark. Like the most that I can think of is and this happens in real life as well, is if there's some sort of like hotspot pricing algorithm, which Uber does have. It's on-demand pricing. Sometimes drivers will get together with like extra cell phones and open and close the Uber app in order to drive up like demand, artificial demand in certain regions, so that they can charge more.
That's why I see these Uber drivers in, you know, like Korea and these other places. They have like 6 phones in front of them and while they're driving a car. Have you seen that before?
I haven't seen 6. 6 is a lot. Like,
That's why they're doing it. Oh, those little grifters.
I don't know if this is fixed or not. I'm just like, I think inherently if there's some sort of, you know, hotspot pricing algorithm, how do you know if a phone that's opening the app and requesting a ride, if that's a driver or a rider? It's kind of very hard to tell from a software system side. But then again, it's like we're trying to describe like what kind of like marketplace attacks could exist. But this kind of attack, as you know, we're talking about now, whether it's built on the chain or not, you know, it's still a attack vector.
Well, the on chain, the Sybil problem becomes orders of magnitude bigger, right? Now that you could create AI bots to drive up demand for anything, especially if
Yeah.
it's on chain. But whereas the Uber example, in meat space, you're limited by the number of phones that an individual can have, and Sybil, right? So it's like capped at you know, the number of hardware you have.
Yeah. I mean, you could also do the same thing with an on-chain app. I don't think that's a blocker to forcing users of that on-chain app to authenticate through a cell phone and be tied to a specific device.
Oh, okay. Oh, that was maybe that was a false assumption I had.
Yeah.
Okay.
Well, it depends on like how you expect people to interact. I wouldn't expect people to be like using MetaMask to like call a ride. I would expect them to have some sort of mobile app, just like Uber today. It's just that like like it would, in my mind, it would stay all the same. The only difference would be that the actual like liquidity of the market is supplied via a blockchain instead of like Uber's centralized database. Like that's the main difference in my mind.
Okay. Okay. By the way, to those listening in the audience, if you have questions for Bo, please do add them in the live stream, and we could address those questions before we close out. And if not, then I would continue with my final question. Let's talk about RIP 7789. And then we'll close out with your housekeeping items and updates. Shall we?
Yeah, sounds good.
Okay. RIP 7789. What tell me about that. And why is it called RIP?
Yeah, so there's EIPs, Ethereum Improvement Proposals. This is the name that they came up with for Rollup Improvement Proposal. The acronym itself is maybe not the best acronym, but the name is I guess consistent with their naming schemes. The actual improvement proposal tries to establish some safety invariants for cross rollup communication. This is not a concern in the Cosmos. Cosmos chains have fast finality, independent consensus. Because Ethereum rollups all share the same consensus, today a big issue that we're seeing is that a lot of interop protocols rely on like arbitrary confirmation depths, which like add some security, but don't really like aren't conducting these transactions with knowledge of this shared L1 state across all these different rollups.
And this is the case because their finality is a function of a chain that naturally reorgs, right? Like all the time, whereas Tendermint chains don't fork at all.
Yes. Although caveated by saying that reorgs don't happen that often on Ethereum L1, except at the head. The head of the Ethereum L1, like 1 to 2 block reorgs are very common. Like 7+ block reorgs are very uncommon. So actually, most rollups are, you know, should be fine in theory, but this is this would feed into potentially like some type of like something that's analogous, like a 51% attack, except it's not crypto economic, but on the actual like software network level of the chain, if there is enough value to be extracted. But so the RP, and instead of going into the technical details, I'll just like provide some intuition. For any of you who have watched any time travel movies, you're probably familiar with like time travel rules, and like basic time travel rules are, if I'm in the future, I can't communicate with someone in the past. Um, like I wouldn't be able to leave a note and for this person. But if I'm in the past, I can communicate with the future. I just have to wait for the past to catch up with the future. And if we're on the same timeline, so like we exist in the same time period, then we can communicate directly. So with rollups, it means that rollups that are building off the same L1 block can communicate pretty much instantaneously, safely. Rollups that kind of have like a divergence in where they sit in the timeline, one would have to either leave a message for the other, and or the other one would have to like wait to catch up to talk to this other party. And I think and then like once they catch up, you're not talking to the future self of this person. You're talking to that version of the person that existed during that time, if that makes sense. It's like if I'm from the past and I wait to catch up, and the future has already technically moved forward. Maybe the future you at the head is like 50, 55 years old. The past you has caught up in time, or like the past person has caught up in time, but they're talking to the version of you that was like 20 years old. And you kind of see this very often in like time travel movies where like you have the same person but like at different ages. Yeah.
So how do you reconcile that?
We add a contingency check. So the way we do it in practice, implementation wise, is we create a contingency DAG across all cross rollup transactions sub Ethereum finality. And the way the DAG works is we call the RP cross rollup contingent transactions. So there's an inherent dependency between contingent transactions with the dependency links that are formed across rollups that's dependent on shared L1 history. So it's just contingent transactions is dependent on dependency links across rollups, is dependent on the shared L1 history across these rollups. And then this DAG itself is either committed or reverted based on whichever version of Ethereum history is actually finalized. So you get this like all or nothing property.
Okay. This all sounds very complicated. Dewey asks, when mainnet? Bo.
It's imminent. I'll say that. Just be like on the lookout for announcements very soon.
Okay. By the way, Dewey, that's a very nice bad kid. I haven't seen one with a Christmas hat on before, but that's a good one. That's a new one. Cool. All right. So do you have any last remarks to let people know about what to do if they want to contribute or if they want to interact with the protocol in some way?
Yeah. So right now, and during mainnet launch, we are looking to work with different types of builders. If you're building like an intent-based like cross-chain protocol, if you're building like a DeFi protocol that needs to be cross-chain, or otherwise, we'd love to chat, or even like an app chain that wants connectivity to other chains. I also wanted to briefly talk about kind of like our long-term goals, and to kind of tie the conversation back to a point that you made in the beginning of the talk, which is we have this PvP nature in the ecosystem, and how can we get out of this like PvP cycle? And I think our perspective there is that we're very PvP because since DeFi was created in 2020, there hasn't been a lot of innovation outside of DeFi that's been successful. So like the number of categories of apps on chain is actually quite small. And because there's so many clones in this existing category of apps, every ecosystem is PvP. We're all fighting for the same pie. And
the same 26,000 individual users on crypto.
Yeah, exactly. Like, because realistically, like the number of DeFi users is not going to grow to 1 billion. I can't imagine 1 billion people on the internet degenning into like different like DeFi protocols and yield farming and that sort of thing. I think that user base will always be limited in its capture size. But these other categories of applications like e-commerce, like social media, those applications have very large surface area. They can capture a lot of users. And to make something like that successful on chain and very competitive with the existing applications, we need to get performance. We need to both improve the performance of chains, meaning that we need to reduce the cost of block space, and we need to reduce the cost of the space between blocks. which Polymer is focused on. We also need to reduce the latency overhead of the applications that are executing on chain. And when we can bring these costs down to something that's comparable to what you can achieve off chain, is when we'll start to see a lot more builders, especially in like Silicon Valley or otherwise, that wouldn't normally build on chain, start to really consider us as a competitive alternative to build versus just building a centralized web app.
So for this service that Polymer is doing, how are you getting subsidized, or how are its contributors getting subsidized?
We will have
Or its stakeholders?
So because we're a rollup, we don't have validators, but we are will work with builders to incentivize builders to build on Polymer and work with. We have like a builders program that will we can collaborate with builders on to bring them into the ecosystem, incentivize them to build cool things.
Okay, gotcha. All right, cool. Any last announcements?
No, that's it. Just wait for just be ready for our next few announcements very soon.
Okay, and what's one key takeaway that you want your viewers to have if they took nothing else away from this podcast?
I think it's just the latency thing. Like latency kills. It kills your performance. It handicaps applications. We need to get that down. We need to get costs down. And like one data point I'll leave folks with is the cost of block space is currently about like 30,000 times more than the cost of writing to a centralized database in the cloud. But the cost of interop, the cost of sending a message between one layer 2 and the next is currently 357 million times more than the cost of sending a packet in the cloud. So like that cross rollup, that 357 million times cost is what the cost that Polymer is really honing in on, trying to bring that down.
Okay. Last question. Daniel asks, is there a rumor that the team raised capital recently?
No, we haven't raised capital recently.
All right. Where can people find you, Doe? Where can people follow up?
Yeah, just ping me on X or formerly Twitter, and my handle is 0xshake.
Okay. And if you're listening to us live and stayed for the entire almost full hour, congratulations to you. These are the greatest alpha seekers in crypto Twitter, I would say. All right. Thanks for coming on, Bo. Good to hear from you. And congratulations on your soon mainnet launch. I will be watching out for that.